So here's a video to fill out our learning card on the law of large numbers. So as we look at this, right here in the middle, we want to say that the law of large numbers is all dependent on just random chance. It's what happens randomly. So we're going to use rolling two dice and looking at the sum of those two dice as our sample space and looking at it as our event. So in this case, our event is going to be the sum of two rolled dice. And we want to know, we're going to say that event A is the sum of two rolled dice is greater than 8. Okay, more than 8. That's what we're going to focus on. Well, the law of large numbers is an example of finding theoretical or finding experimental probability and comparing that to theoretical probability. So in this space right here, what we want to say is this. The law of large numbers is very erratic in the short run, but becomes predictable in the long run. And what we're going to be looking at again is comparing the experimental probability with the theoretical probability. So we're going to start off like this, and we're going to look at what is the probability of A. In other words, what is the probability that the sum of two rolled dice is greater than 8? Well, if I look at my sample space over here, I can see that the sum being greater than 8 would be a 9, a 9, a 9, a 9, a 10, a 10, a 10, an 11, or a 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of the total sample space, which is 36. So the probability of A rolling a sum of two dice that is greater than 8 would be 10 out of 36. So 10 out of 36 is about 28%. So that's what we're looking at right there. Well, let's take a moment and let's take a look at the probability of the complement of A. So this little symbol right here, A with a little apostrophe, is the complement of A. So the probability of the complement of A would be the probability of not rolling a sum of two dice that is greater than 8. So in this particular case, it would be rolling a sum that is less than or equal to 8. Well, if the probability of A is 0.28, then the probability of not A would be 1 minus that, which is 0.72. So what we have up here, the probability of A rolling a sum that is greater than 8, this right here is the theoretical probability, about 28%, or there's a 28% chance of this occurring. But what about the law of large numbers? What about the experimental probability? Well, I have two dice over here, and I'm going to roll both dies, and I am going to keep track along the bottom with my roll numbers, and I am going to look at the probability that I roll a sum that is greater than 8 based off of this experiment. So follow along with me. Now, if you do this with your own dice, you'll have a little bit different probability as you go, but let's take a look and see what happens. So I'm going to roll the two dice right now, and I get a sum of 12. So right now, after one roll, the probability that I roll a sum that is greater than 8 is 100%. So I'm going to put a dot right here at 100% because I've rolled it once, and 1 out of 1 times I rolled something that was greater than 8. But let's go ahead and do a second trial. So here we go. Here's my next roll, and I got a 6. Well, 6 is not greater than 8. So what I have now is 1 out of 2 rolls is going to be a sum that is greater than 8. So now I'm at 50%. So I'm going to put a dot right here at 50%. After 2 rolls, the experimental probability of rolling a sum that is greater than 8 is at 50%. Well, let's roll it again. Here I got 6 again. So now only 1 out of 3 rolls did I get a sum that is greater than 8. So 1 out of 3 is 33.3%. So I'm going to put this right about there. right at about 33%. Okay, let's roll again. So I get 4. So that means 1 out of 4, which is 25%. So now I'm down to 25% being my experimental probability of rolling a sum that is greater than 8. I'm going to continue to go here. There's a 6, that's not greater than 8, so now I'm at 1 out of 5. Well, that's 20%. Okay, there we go. Roll again, and I get 6. So that's 1 out of 6. 1 out of 6 is 16%, which would put me right about here. Now you can see that things are kind of erratic, and if I were to connect these with a line, let's go ahead and do that right now. If I connect these probabilities with a line, it would look something like this at this point. Now it seems to me like it might be, I might be seeing a pattern here, but this is the law of large numbers. This is something that we do over a longer period of time. So I'm going to go ahead and roll about 5 or 6 more times and show you the results. I'm going to pause the video and do these rolls, and I'll show you what happens over a longer period of time as I go. My next roll ended up giving me a 10. So that gives me 2 rolls out of 7, which gave me a sum that was greater than 8. And 2 out of 7 is 28.5%. So I'm going to go ahead and put another dot at 28.5%, which is right about here. And then I'll connect those. And when I connect them, I get here. I'll go ahead and do another roll, and so let's see what happens. I was going to do it off screen, but let's do it here. So there's 10 again. So now that's 3 out of 8, which is 37.5%. So after 8 rolls, my experimental probability puts me right about here. And let's do another one, 9 rolls. That's 6, so that means 3 out of 9. That puts me back down at 33%, which is going to be right about here. So again, if I connect the dots, you can see that in the short run, things are kind of sporadic and they're kind of erratic and all over the place. Now I'm going to pause the video and do about 20 more rolls, and let's see what happens. So I went ahead and rolled about almost 20 more times, and what I ended up getting, or what you can see here, is that the probability jumped up, and then it started to work its way down, and then it jumped up a little bit more and worked its way down, and jumped up just a little bit more, and then it started working its way down. And 28% is right about here. So you can see that the very last one that I did, I was right at 28%. It ended up being 9 out of 32. Now, if I continued, would I eventually fluctuate a little bit above 32% or a little bit below 32%? Or I say 32, I should have said 28%. A little bit above 28% or a little bit below 28%? Sure, it will. It'll fluctuate a little bit based on every new roll that occurs. But you can see that the law of large numbers shows that what eventually happens is that the experimental probability, the more you run an event over and over and over and over again, the outcomes, the long-term outcomes, when you put them all together, will get closer and closer and closer and closer to the theoretical probability. So to say that again, the law of large numbers says that the more you run your experimental probability, the closer the experimental probability will get to the theoretical probability. So hopefully you've learned a little bit about the law of large numbers and what it means, and I hope you have fun in your stats.